Thanks, Danelle, and a good afternoon to everyone. I'm Tony Bergantino, Director of the Wyoming State Climate Office and the Water Resources Data System. Welcome to the May Conditions and Outlook briefing, which is brought to you today by my office, along with, as Danelle said, University of Wyoming Extension, USDA Northern Plains Climate Hub. We have the U.S. Geological Survey, the Wyoming State Engineers Office, National Weather Service folks, National Natural Resources Conservation Service, Bureau of Reclamation, Bureau of Land Management. I hope I haven't forgotten anybody here. We've got a pretty full set of presentations, and we'll look at the current drought, climate conditions, surface water conditions, and reservoir operations, weather, flood forecasts and outlooks, water rights administration, followed by the highlight of the month, which is going to be water supply forecasting methods. So without further ado, we have the current U.S. drought monitor map. It was hot off the presses from this morning. Shows the state of conditions through the 14th or Tuesday. Even though the last webinar was only 3 weeks ago, there have been quite a few changes in terms of the area affected. Some good, such as the areas in green, which saw enough precipitation to warrant some improvements. On the other side, there was a very large section of eastern Wyoming that has seen below normal precip, and consequently, we have some degradations in this large section of red. One thing to note is that the highest category of drought in Wyoming now is the moderate level, since the area of severe drought in the Bighorns has been improved and was removed. The map on the left shows where we were a year ago. The map on the right is the one from today that you just saw. Somewhat similar in the amounts of each category, except that last year, as I mentioned, we still did have some of that severe. Actually, no, we didn't last year. That was just last week, so we'll skip that. We had severe drought down in Goshen going down into Laramie counties there, and none of that's on the map right now that we lost that Bighorn severe drought. With only 3 points added to the chart since the last time we met, there isn't a whole lot to point out here other than less than half of the state is covered in the abnormally dry through exceptional drought categories. We got 20% of the state in drought at the moment, which is up just minimally from last webinar, hardly even worth mentioning the difference. The total percentage is about the same, but we did lose roughly 2.5% of that severe drought and made up for it with some inclusion of some more abnormally dry conditions, especially down in southeastern Wyoming. Here's the more detailed look at roughly the last 4.5 years, basically just before that last major drought started. So beginning of January 2020. Fairly even lately, with percentages changing only 2 to 3% since the last webinar. About 20% of the state, as I said, is in moderate drought, and a little over 26% is in abnormally dry conditions. Let's look at precipitation over the last 2 weeks in terms of percentiles, and quite a bit of those blues and purples on the map. Those indicate precipitation amounts over the 80th percentile, which is pretty good. Unfortunately, the southeast does not have any of those colors, and instead is showing precipitation down under the 20th percentile, so kind of the reverse conditions. Some areas even under the 5th percentile down in southern Albany and in Laramie counties. Looking back 90 days or about 3 months, much of Wyoming at median or above, although the east, especially the southeast, is under median, and this corresponds with that large area of degradation that you saw on the drought monitor map earlier. The northern winds and Tetons have also been missing out on some of the precip the last 3 months or so. All right, fairly similar stories looking at the water year on the left compared to the calendar year on the right. Southeast and Northwest are below average at both time frames. Looking at the calendar year, eastern central Wyoming, as well as the area east of the Bighorns, has received below average precip, while at the water year time frame, those areas are in better shape. Conversely, the Northeast has improved in the more recent period covered by the calendar year compared to when you look at the water year depiction. And this is the Standardized Precipitation Evapotranspiration Index, or SPEI. It's the standard precipitation index map that has usually been shown the last several webinars, but it adds the component of evapotranspiration, so you get a better view of the water balance, water coming into the system and then the water leaving. 30 days on the upper left shows an improvement in the southeast and the northwest when you compare it to the 2-month time frame on the upper left. We also have more of the state on the wet side of the index in the shorter time period. The depiction for a full year is pretty wet. Only the northwest and far south central areas being about neutral, and hardly any below neutral or the dry conditions showing up there. North central Wyoming is appearing quite wet at this longer time period. Again, a lot of that, you're still seeing some of the influence from the early summer and spring last year. I can move on here. 14-day average minimum temperature. We'll look at first the minimum temperatures. Actual temperature on the upper left. Most of the lower elevations are now seeing those nighttime lows that are not getting down below 32 anymore, and it's been warmest in the north and the east. On the lower left, the map shows departures from average, western Bighorn Basin, as well as the northeast, along with Platte, western Goshen counties. Just been a bit above average, while the south central area has been up to much as 6 degrees Fahrenheit below average, along with some of Lincoln County and the winds and southern Park County. Rest of the state has generally been up to about 3 degrees below average. Going to the other end for high temperatures, again, the map on the upper left shows the actual temperatures, and statewide we've had daytime highs above to well above freezing, with eastern plains and the lower elevation north being in the mid and even upper 60s. Like the low temperatures, the highs have been below average, and even more so for the high temperatures compared to the low. Only far northeastern Wyoming was a bit above average the last 2 weeks, with the rest of the northeast, the east, a little bit of the northwest being up to 3 degrees below average. South central Wyoming, along some areas over there in the west, are up to 9 degrees below average, with the rest of the state coming in around 3 to 6 degrees below average. Come on, soil moisture here. Some nice improvements in the north central, northeast, along with moderate improvements in the west. The southeast and far northwest have lost some ground, or at least some of the moisture in that ground. Look at basin snowpack numbers. Here's percent of normal or percent of median. When you start to see asterisks next to the percentages, like you do here on the Bear and Lower Green, it means the conditions are such that the percentage might not be a good representation of ground conditions. This often has to do with the amounts present at this point in the season, or how different the median or the actual snowpack can be from one day to the next during meltout. Last month I mentioned that real steep melt-off curve. So, one day either side of that, you can have quite a bit of a difference compared to a median. West central and northwestern basins are under their median, while the rest of the state is showing above, except for basins like the Belle Fourche, Cheyenne, South Platte, and Wyoming, which are essentially melted out now. They were actually melted out earlier. Then we had that latest round of snow, which popped them back up, and now they're down to about zero again. Just a quick look at aerial snowpack or interpolated snowpack across the state. This is from remote sensing and ground stations, interpolated from them. Like the basin map we just saw, the percents here can start to vary pretty dramatically this time of the year, but relatively speaking, you can see areas like the Sierra Madre is not doing as well as last year, while the northern Laramie Range and southern Bighorns are showing just a little bit better. You're seeing some actual blips there, whereas last year that was basically all melted out. Departure from median. Now the last map showed conditions compared to last year, this year versus last year. This map is showing a comparison of current conditions to the median. And what stands out is the lower elevations generally being well below median, while many of the very high elevations, those bright pink colors, are actually doing much better than the median. Basin peak snow water equivalent. Since the last webinar, an additional 2 basins reached and exceeded their median peak snow water equivalent for the season. The 6 basins that have, those are the blue values in that the 6th column. Bighorn Basin actually hit its peak yesterday, which was 21 days earlier than normal. And you can see others like the Wind and Shoshone, which reached their peak snow water equivalent about 3 weeks early. And while the Wind's peak was 90%, 96% of median, the Shoshone was only about 86. The Sweetwater Basin, that's in the central Wyoming, that was over 3 weeks late reaching its peak snow water equivalent. And that value was also almost 2 inches higher than the median. To look at more of this, I invite you to check out that link down there in the lower left. A lot of link charts from this table here, so you can just sort of play around and get a feel for what things are doing around the state and where they're going. I'll close out here with showing the chart on 2 basins. The Powder River Basin there on the left, that was our poor performer for almost the entire season. And as you saw on the map, it's now at 113% of median, thanks to some very late season snows that somewhat turned things around. Despite those snows, though, the median peak was never reached, and the median value is only that was only busted through in the last 10 days or so. And the snow that fell is being compared to normal conditions that are usually well into a meltout. The chart on the right is that Sweetwater Basin I mentioned earlier. Fairly normal season, almost hit the median peak value, albeit much earlier than normal. But after it seemed to melt out, started going down pretty good and then you got a late season boost and pushed the basin well above the median, and then also exceeding the median peak by almost 2 inches. As Yogi Berra said, it's tough to make predictions, especially about future snowpack. And on that bad note, I'll pass the mic over to Aaron Fiaschetti with the USGS, who's going to talk about surface water conditions. So go ahead, Aaron.
Thank you, Tony. So here's a look at current conditions here across the state. This is from our National Water Information Dashboard, and I'll just run through the colors real quick, and these will be consistent throughout the presentation. So green is what the USGS considers the normal flow. That's a 25th to 75th percentile. So 25th pretty low, 75th pretty high. So that's your kind of normal range. And then we have some blues, light blues up there that are above normal. That's the 76th to 90th. And then some dark blues, which are much above normal. And thankfully here, we don't have much yellows, which are below the 25th, or reds, which are below the 10th percentile. So just right now, kind of playing off of what Tony had to say is, yeah, we have a fair amount of water moving around. We're kind of at a time where runoff is beginning, and depending on where we're at with things melting off or cooler weather or hotter weather moving in, we'll see these kind of bounce around when you're kind of looking at a real time or daily value. So next slide, please, Tony. So this is a product from Water Watch where it's showing an amalgamation of gauges for the state, and it's the vertical axis is a 7-day average runoff in millimeters. So it's a flow divided by area kind of. But the important part here is the black line and just kind of showing where we are. We're on the upswing of runoff, and you can kind of see, similar to what Tony was showing with the Sweetgrass, where we kind of reached a peak, things started to melt off a bit, and then the cooler weather where snow kind of continued to accumulate, and then things begin to melt off. So that little dip. So, you know, things can move around a bit when we're kind of moving on the upswing of this rising limb towards a peak flow. So we'll kind of see that depending on what the weather, but expect if things kind of start to warm up and or rain, that things will kind of move towards the other end of the spectrum and be farther away from the 25th percentile and closer to that 75th and above. So yeah, just consideration, these grain of salt kind of caveats throughout the presentation. So let's kind of move around the state and kind of look at where runoff is. So up here in the northwest corner, the North Fork of the Shoshone, you know, kind of going, this is a water year, October 1 through current hydrograph here. Colors are similar to what we've shown before, that normal in the green. But as of lately, kind of things were trending up pretty high in the April and May, above the 75th percentile. And then we had a dip off, and now things are kind of solidly on the upswing in that area. And we're probably a couple weeks from a normal peak. I guess it remains to be seen if this year's peak flow will be the timing of it, if it'll be before, around, or after a normal peak. So that's, I guess, depending on the weather. So, but as of right now, things kind of look pretty good in the, as far as the current stream flow in the Northwest. So moving over to the Powder, this is the Middle Fork Powder near Barnum. Things have been pretty high as of lately, pretty consistently above the 75th percentile, as it's we get snow melting off or rain moving through, that the flows kind of tend to bump up. And this looks like we're pretty close to about the normal peak for that site. So we'll kind of see how things go forward on when that falling limb starts to come down. Moving down to the southeast, the North Platte above Seminole here. Pretty similar pattern where we started to see some runoff start to occur here in April, and moving above the 75th percentile. And some of that can be that there not was so much water there, but the water was coming off a little bit earlier and kind of driving those flows up, but certainly within the realm of what's been observed before. And then a pretty recent decline in flows, and we've kind of yet to see that swing back up and get back into runoff in earnest. So looks like about a month away from the normal peak flow there. So we expect to see things continue to rise in that area. And then moving over to the Snake River above Jackson Lake. So pretty higher elevation site. We're still kind of, things have dipped off quite a bit there in the last couple weeks, hanging in that 25th percentile, but rising back up as cooler weather's kind of moved through the area. But things are kind of climbing back up, and yeah, we're a couple weeks out from a normal peak there. So expect to see, as the higher elevation snow starts to melt out, that site goes up quite a bit. Looking at reservoirs here, here's the May 15th compared to April 15th. There really hasn't been a whole lot of change in storage for most reservoirs, probably due to just not a lot of water moving around previously, and now we're kind of starting to really move into that upswing of runoff. So most reservoirs are 60 to 80% full. And then just one note of change is, it seems like Palisades is being lowered a little bit. It's decreased 11% since April 15th. So I guess expect those numbers to change quite a bit towards the positive, I would assume, for next month's. That's all I have. Thank you, Tony.
Thanks, Aaron. With more on the surface water situation, we have George Finnegan, who's with the Bureau of Reclamation, to talk about reservoir ops. Go ahead, George.
Sorry, George, I'm not able to hear you. Tony, can you hear George?
I don't.
George, I see you're unmuted, but for some reason We had your audio earlier, so.
Maybe the audio input.
Yeah.
There you go, George. Thank you.
Okay, you're welcome. I'm sorry about that. The spring runoff season's upon us. Inflows into Bull Lake and Buffalo Bill now exceed outflows. We're beginning to see increases to the reservoir contents. Boysen inflows are less than outflows, and we're still making space for the snowmelt runoff, but we expect inflows to catch up in the coming days and weeks. And we'll go to the next slide. Outflow from Buffalo Bill is 1,300 CFS as measured at the Cody River gauge. Outflow from Boysen is 2,200 CFS. Outflow from Bull Lake is 31 CFS. Expect all reservoir releases to increase as the spring runoff season progresses. Under our current forecast, we expect to have more water available than is needed to fill the system and will be increasing releases as we simultaneously fill the reservoirs. Changes to the reservoir releases can be found using the link or on the screen. Let's see. Yeah. We'll go to the next slide. And we've got the North Platte system here with a Seminole content of 650,000 acre feet, which is 64% of full and 118% of average. Pathfinder's filled to 780,000 acre feet, which is 73% of full and 125% of average. And that's a total of 111% of average for the total system. Now, Glendo is at 416 or 417,000 acre feet, and we're keeping it low because of the precipitation we've been receiving and preparing for runoff. Let's go to the next slide. Reclamation is being cautious raising Glendo due to the large precipitation event in the Glendo watershed around May 12th, which was just a few days ago. But we're at full power plant capacity coming out of Seminole to Pathfinder and making some room for the runoff. Great Reef is releasing a substantial 1,500 CFS, but we're holding back a little bit there for Glendo. And our irrigation demand is 3,000 CFS coming out of Guernsey, and we're matching that at Glendo. Demand is expected to taper off during early June before the demand comes back for the regular irrigation season. Right now, we're in the May hay run, and that's going very well. Summer precipitation is expected to be dry, but I'll let the National Weather Service cover all that. So thank you.
Thanks, George. Well, the State Engineer's Office folks would normally present this section, but they're out in the field this week. There are some areas of regulation in effect, so we wanted to put up this first slide here. Administratively, the state is broken into 4 divisions, with the Board of Control having a superintendent in each of those divisions, and those superintendents are listed here next to their respective division along with their contact information, and they would be the ones that you would want to get a hold of if you had questions about what was happening in a particular division as far as regulation or anything like that. As of Tuesday, there were 3 streams under regulation in Wyoming. All those are in Water Division 1 in Southeast Wyoming. The Laramie River is under regulation for rights back to 1898. Soldier Creek and Horse Creek are both being regulated to 1884 rights. And again, for more information on these, you can contact the superintendents that were on that previous slide. So next up, we have Tony Anderson, who's with the National Weather Service over in Cheyenne, to give us some idea what to look for over the coming weeks. Go ahead, Tony.
All right. Good afternoon, everyone. My name is Tony Anderson. I'm the Senior Service Hydrologist at the Cheyenne office of the Weather Service. I provide support to the Riverton office as well. So I cover most of the state in one way or another. But jumping forward, and since I'm a hydrologist, I'm going to step out of my comfort zone and give you a weather briefing. So this is a great chart that Lance put together from Riverton, and it just kind of highlights what are the hazards, weather hazards that we're looking at the time of year, highlighted in the yellow area. And it's springtime, so we are moving into severe thunderstorms, tornadoes, and then plus, depending on the snowpack and the melt, the river and flash flooding potential that can come with the springtime. Somebody has mentioned in the questions about fire weather. We're just starting to get into our traditional fire weather season, and so that will be a concern moving forward, depending on how much rain we get and in what what's what kind of timing we have on that rainfall. So next slide, please. Okay, looking at the 7-day precipitation forecast, it looks like we're gonna be moving into a drier and warmer and windier weather for the next 3 or 4 days across the state. It's gonna be more May-like. Little less certain afternoon potential for afternoon rain, afternoon thunderstorms, but fairly dry for a few days with that wind, with those windy conditions. But chances of precipitation increase on Sunday and Monday, and we're expecting a system in that time frame. But even with that rain, we're not expecting a lot of places to get more than an inch of precipitation. The main area for that will be up in the Bighorns, hopefully, because that will help relieve the drought that's been going on there for quite some time, even though we took a big chunk out of it this last week. Next slide, please. Okay, moving out, we've just looked at 7 days. We're going to look out from days 8 through 14, and these are temperature and precipitation outlooks, just more or less giving you what are the signals telling us. It's not so much a forecast as what are the global signals telling us that we might expect in that time frame and that second week from now. So looking on the left, looking at the temperature outlook, we've got a fairly strong below normal signal up in the northwest, and that weakens into a moderate signal across the bulk of the state. And then down in the southeast, we've got a weaker below normal signal. So the signal is telling us our best forecast is probably going to be on the cool side for that second week from now. Jumping over to the precipitation outlook, we don't have much variability in it in the state of Wyoming. We have a weak above normal signal for precipitation for the entire state. So below normal temperatures, above normal precipitation, that's a combination you kind of expect. But it's a fairly weak signal on the precipitation, so I wouldn't bet too heavily on that. Next slide. Jumping out, same kind of analysis, only pushing it out to a full month from now. Once again, we have dropped from below normal to above normal temperatures signals, and it's a strong or a moderate signal across the bulk of the state. There's really no signal up in the extreme northeast, and then we have a transition zone between no signal through a weak above normal temperature or above normal signal and into a moderate above normal signal covering the bulk of the state. So look for above normal temperatures in that over the next month. On the precipitation side, that signal we saw in the second week really weakens for the whole month. We actually have no signal whatsoever. So our best forecast right now would be the climatological averages. That's basically what that equal chances is telling us. So don't look for any extra rain, although the potential's still there, and look for above normal temperatures, which does not do good things for our fire outlooks or for the drought outlooks. Next slide. Okay, we also do water supply outlooks at the Weather Service as well as those provided by the Natural Resource Conservation Service. These are the percent of normals from the Weather Service water supply forecast for the April through September stream volume flowing past the observed points. So they're color coded. The earth tones are below normal. The cooler blues and greens are above normal. And you can see the southern part of the state's actually done fairly well this winter. We're expecting normal, near normal to slightly above normal forecasts, especially in the Platte River that's Tony's highlighting right now. If you move over to the Colorado Basin into the upper green, they didn't do as well on their water supply forecasts. So we're looking at some more of those yellows and oranges down there in that system. There's a few greens in there, but generally speaking, we're looking for below normal runoff for the season from those areas. Across the north, it's more of a mixed bag. We got some blues, we got some greens, we got some oranges. The bighorns are not doing all that well, even though they got that big boost recently. And the next forecast that we do at the beginning of June may actually change that a little bit. But elsewhere, it's a mixed bag across the north. We got a big number coming out of the bighorn, and we will see how that how that verifies. But kind of a strange mixture up there in the north. I think that's everything I've got, so I will pass. Oh no, I take that back. I've got one more. Looking at the my apologies. Looking at the Wyoming flood potential. This slide, we run long-term models going out 90 days, and we ascertain what our models believe is the probability of reaching flood stage, moderate flood stage, and major flood stage are. And right now, this is the 50th percentile graphic. So right now, the only place in the state that we believe has a 50% chance of flooding this year is the North Platte River at Saratoga. Otherwise, the rest of the state, normal to below normal chances of flooding. And if we dropped those numbers to the 10, one chance in 10 or one chance in 25, some more places show up. But right now, pretty well below normal chance of flooding. We'll see how that changes with the additional snowfall that we've gotten in the last week, plus the additional precipitation that's coming, hopefully at the end of this 7-day period. Now I think I'm done.
Now you're done, Tony. Thanks. All right, to go over wildland fire potential and outlook, our next presenter is Casey Cheeseborough with the Bureau of Land Management. Go ahead.
Hey, good afternoon, everybody. I always start this section off with just a quick slide here to talk about a couple terms I'll use as we talk about fire dangers, because they're not things we use in our everyday vocabulary. So talking about with fire danger, a couple things that it really hinges on the moisture in fuel. So the fuel moisture content, how much moisture is in those fuels that are out there in the wildlands, and along with weather, which we can't, at least I can't change anyway. I don't think anybody on here can. We can just predict it. So don't have a lot of say in that one, or the topography wherever the fire starts. So kind of the one thing we really focus on is that fuel moisture. We talk about wildland fuels that are out there, usually break it down into live fuels. Obviously, those are the fuels that are out there alive, and their moisture content really depends on that individual species of plant, their phenology, the time of year, green up and dormancy, those types of things that vary pretty widely in our plant species out there. Just for reference, when they do go into dormancy in the fall, a lot of times we'll start to refer to those as a dead fuel, just because they give up so much of their moisture going into the fall and winter months. So that brings us to dead fuels, all those dead grasses from last year, twigs, branches, dead trees, depending where you're at in the state, different varying amounts of that across the state due to disease and whatnot, different insects and things. But really with the dead fuels, the big thing is that precipitation, that relative humidity, ground contact, soil moisture to some extent if there are fuels that are laying on the ground. But really, we break those down into 4 different categories. Our 1-hour fuels, which are a 1/4 inch or less. So you're talking grasses, forbs, those types of things. 10-hour fuels, 1/4 inch to 1 inch, small twigs and branches generally. And then our 100-hour fuels, 1 inch to 3 inch, so larger branches, small trees. And then our 1,000-hour fuels out there are greater than 3 inches, so down logs, large branches, those types of things. Again, just focusing with those terms on the dead fuels that are out there, and those times that are attached to those labels are to really simplify it, basically the amount of time it takes those fuels to substantially gain or lose moisture. So you're looking at that 100-hour fuel being about 5 days or so, 4 or 5 days, and then your 1,000-hour fuels being a little over a month or so to fully dry if we have a dry spell of weather. So pretty long-term drying needed for those things to give up moisture. And then our fuel loading, we measure in tons per acre. Obviously, that just really depends if you're down in the grass and shrubs or up in the heavy timber, what that fuel loading looks like. But if we jump to the next one, Tony, and explain one more term here. So energy release component is really just to simplify, I guess, a little bit, is the amount of energy that those fuels will give up. It's measured that. It's kind of a composite of those different fuel moistures that I just described. And so they blend some of those numbers together to come up with this energy release component. This is one of the key things that we look at as fire managers when we're trying to predict ahead and look at staffing, make sure we have enough staffing and those types of things, make those types of fire management decisions. So as you're looking at these graphs, these are in relation to the historical values. And so the blue line on the graph is the current value that we're sitting at. The gray line you see there is the average for this for any given time of year. And then the red are our maximum values for this time of year. And then there's a couple of gray solid lines there. Those are the 90th percentile and 97th percentile. And those are really key numbers that we really hone in on making those fire danger or fire business decisions. Really about that 90th percentile, we'll start talking about increasing our staffing, bringing in other resources. Definitely at 97th percentile, we'll see our regional counterparts starting to shift things our way and start to see more assets come into the state or into the area if they're available. So this one here, looking at what we call the Devil's Tower area. So you can see the map up there, kind of this northeastern part of Wyoming. And thought that one was interesting. Last time we presented, we were right up there setting maximums for this time of year or close, well above average. And as folks kind of mentioned, saw some significant moisture up there in the last month that dropped those down. You see it climb back up a little bit in early May, and then recent moisture again dropping that back down. So sitting right now below average, but you see how quickly and how much that can fluctuate over a month or so. So no real concern there now, but we do catch another dry spell here in late May. It could be an area to keep an eye on with those drought conditions long term there. So did throw in the 1,000-hour fuel moisture graphs this time. So looking at those heavier fuels, this is that Devil's Tower, northeastern Wyoming area again. And this makes sense. Our ERCs, when our ERCs are low or that energy release component is low, a lot of times that's because our 1,000-hour fuel moistures are high. So high fuel moisture is less fire behavior. So we're well above average right now there in those 1,000-hour fuel moistures. And see it's starting to drop with just a couple of days there of drier weather. So another indicator of how this starts to shift over time. Next one, Tony. Looking again at that energy release component, this time over more in that northwestern part of the state, looking in the Shoshone National Forest area. And you see this one is above average, not quite at that maximum level, but that jives pretty well with what the Weather Service folks were saying of the past weather there. So not a real concern right now. Again, back even though we're above average for this time of year, we're still well below those 90th percentile, 97th percentile values there. So not a big fire danger concern, but maybe a signal going into our fire season that we're a little drier than normal in that area. And that next slide has that 1,000-hour fuel moisture again on that. Kind of see that one just right around those maximum values, or I guess it'd be a minimum value. Sorry, let's get these backwards when we go from ERC to fuel moisture. But below average again and close to those minimum values historically, but still again not near those critical levels as of yet, which would be expected here in mid-May. Go to a couple more areas around the state. Looking down in the Great Divide Basin area, pretty similar to that northeastern part of the state. Looking down the southwestern part of the state here, and still ERCs not well below, but significantly below average there, and well below that 90th, 97th percentile. So again, recent moisture there, and then a little bit of a drying trend in the last week or so. And 1,000-hour fuel moistures there. Those heavier fuels were fairly high, up there above 20, around 23% in those fuels, but now coming down, just dipping below 20%. So starting to see those taper off. If we do get that continued dry weather, you can see what just a month or so did there. So if we were to stay somewhat dry through the rest of May, you might start to see that come down to some areas we'd be a little more concerned about. Jump to the next one, Tony. I think so going over to that Laramie Range area, looking kind of down there, Pole Mountain near the Colorado state line, near Cheyenne. We talked about that area being relatively dry here lately, but picking up some moisture. Kind of shows here in the ERC graph. We were tracking with our ERCs above average. Things had climbed up there fairly well, and then this recent moisture the last week and a half or so got that down now well below average and well below any areas we'd be concerned about right now. That 1,000-hour on the next slide, see that one again, kind of an inverse, that fuel moisture climbing up, just getting above average right now. So we'll kind of see. Again, I would say that every time, every slide, but we'll see what the weather does. And I would say there's really no point in the year where that statement is more fitting than it is right now in mid-May. You know, people always ask in the early spring, what's fire season going to look like? What's our fire danger? Those types of things. And I would say this is that time of year where we really start to come into focus a little bit on what things are going to look like. And when you look at some of the bigger fires, you know, down in Snowy Range, the Badger Creek fire, Squirrel Creek fire, going back to 2012 with that fire. Some of those were fairly early June fires. So by the time we present in a month, those fires would have already happened in those respective years. So we're kind of in that time frame where a couple dry weeks of weather can really start to change things pretty quickly for us, even though it's hard to predict a month out, but we are definitely in that time frame. So I suspect next time we talk, we may be talking about specific fires and not just predicted fire danger out there. So, got a couple national picture slides there next that we can look at. A reason I like to throw these in when we're talking wildland fire response and fire danger, one of the big things that comes into play is just resource availability, the availability of our incident management teams, the aircraft, hotshot crews, engines, things like that. And so as we get busy fire seasons around the country, sometimes Wyoming doesn't rank out quite as highly as areas like, say, California or heavily populated areas in the Northwest or whatever. So I'd like to look at this one as well and paint a little bigger picture. So this will caveat, these come out at the first of the month. So usually when we do this presentation, kind of in the middle of the month, these can be a little bit outdated, but this is the one that came out on May 1st. Seeing some a little bit of significant fire potential down in the Southwest. That makes sense, getting into their core fire season here in May and June down there before the monsoon set in. And it looks like expecting that to widen a little bit going into June, that Southwestern fire potential would expand a little bit. Texas, Arizona, New Mexico coming up right there to southern Colorado, right at the border. And we saw this last year. This makes sense a little bit. Folks, I'm sure, have seen some of the wildfires in Canada. So we are seeing just that little bit of the northern or the upper Midwest with some significant fire potential in June. Had a really dry winter up in some of those areas. So there's some potential there. And then kind of a season, normal fire season down in Florida, or normal time of year for that to be kind of more of a hot spot for a little while before they get summer rain. Going to July and August. So going into July, we see, and really for August, not a lot of change there other than that fire potential in the Southwest does start to decrease a little bit, timing up likely with the predicted monsoons in those areas. But the fact that they're keeping that in there in July and August tells me maybe not looking at quite as widespread of a monsoon, which can affect fire behavior here in Wyoming significantly as well. And then up there in the Great Basin, looking in Nevada, Idaho, Utah, that area, expecting July and August to be fairly busy up there right now, and then a little sliver up in the Pacific Northwest as well. So those are the types of areas that can really pull resources away from Wyoming if we were to get busy here. A couple other things I would just point out. let's see, the Weather Service mentioned it a little bit, but not just the quantity of moisture becomes a big deal, but the timing of it, right? A couple of years, I think it was 2 years ago, we had a somewhat dry summer, but the moisture that we did get was just really, really timely. It came about every 5 or 6 days, it seemed like, across the state. So we had a pretty slow year. And then last year, pretty widespread moisture throughout the summer across the state, as folks know. And so with that, we've got quite a heavy dead grass component out there on the landscape as well. It's pretty overshadowed right now with all the green up going on statewide, but I would expect that if we do start to dry out later in the summer in those areas, that dead grass from last year could play a role in making fires a little bit harder to contain and harder to suppress. So I'll leave it at that. Thanks, Tony.
Good. Thanks, Casey. For our highlight of the month, we actually have 3 people on here. We have Kevin Foley with the Natural Resources Conservation Service, Alex Crothers with the National Weather Service's Missouri Basin River Forecast Center, and then we have George Finnegan again with the U.S. Bureau of Reclamation, and they're going to be talking about water supply forecasting methods. And we'll start out with Kevin, and they can pass the baton back and forth as needed.
Awesome. Thanks, Tony. Just clarification, I think I was going to do the Bureau's presentation as well, not George. That's how it was explained to me. Unless George really wants to do that, but it sounds like maybe.
I see a thumbs up, so I think George is turning it over to you.
No worries. Yeah, so I'm Kevin Foley with the NRCS's National Water and Climate Center. I'm a hydrologist, and I am the water supply forecaster for the eastern-facing basins of Wyoming. So really quickly, in a really short time, I'm going to just go over a broad overview of how the NRCS creates and issues statistical water supply forecasts. On the slide, I just have a screenshot of our current water supply forecasting software. This is called Persephone. And I'll kind of go over in a bit here what all goes into the software. Next slide, please. So traditionally, the NRCS has used a linear regression approach to coming up with water supply forecasts. Just a bit of background, a water supply forecast is a volumetric forecast. It's the total amount of water flowing through a point between April 1st and July 31st, or May 1st and July 31st, et cetera. And this is how the NRCS used to do it. We used to go out and get a bunch of snow data from SNOTEL sites, mountain precipitation data, and we would come up with a relationship between these predictor variables and the April through July stream flow, and it was always this kind of linear relationship, and that served us well, going back almost 100 years, right? In the last 4 years, next slide, please. The NRCS has started transitioning away from that linear approach to try and increase the skill of our models using new computing techniques. So we've started using an ensemble approach to water supply forecasting. This is an ensemble of machine learning approaches as well as our traditional linear regression approaches. What this means is instead of this very basic linear regression model, we're now looking at 6 independent types of regression models from left to right: principal components regression, quantile regression, support vector machines, artificial neural networks, quantile recursive neural networks, and random forest models. I put this little image down the bottom to kind of explain the fact that we're not really going for this linear approach anymore. And hopefully the trade-off is that while we're gaining a lot of skill from these machine learning methods, we are losing a little bit of explainability. So it's not as simple as, the April through July runoff is, correlated very closely to 4 times the snowpack plus 5 times the precip, right? You have these much more complicated models that are less easy to explain, but do end up being more skillful. Next slide, please. So the NRCS issues forecasts on a monthly basis, starting on January 1st. ending on June 1st for over 600 points across the Western United States. We publish all of those forecasts every month on our interactive map and in our forecast charts. You just Google search interactive map or NRCS forecast charts, and these two results will show up. And I put over there the May 1st forecast in this left picture. So we have 7 forecasters that are responsible for creating all 650 odd forecasts every month. And myself, I do the eastern side of Wyoming, the Yellowstone Basin in Montana, and the eastern side of Colorado. So I think that's all I have for the NRCS. I'm happy to go into any more detail later on if we have time.
Credit, right? So they bring
Okay, I think it is my turn. I'm Alex Carruthers, a hydrologist at the Missouri Basin River Forecast Center, and I am our water supply focal point. And I also am the primary forecaster for the Bighorn and Yellowstone basins. The Missouri Basin River Forecast Center water supply and all of the National Weather Service water supply forecasts are probabilistic, similar to how we produce our ensemble stream flow predictions, or ESPs. So a typical day for river forecasters, we come in and we balance our river. So we try to take what we have modeled to match the observations. We can do this by modifying the model's current conditions. So a couple examples, we can change the amount of rainfall, snowfall, the rate of snow melt. We can alter soil moistures. We save these changes, and that saved, what I'm calling a saved state, is the initial starting point for our ESPs. We use historical and climate data to run the model from that initial start date. So for today, that would be starting with May 16th's current conditions. And then we run from that date until the end of the water year. This gives us a range of possibilities for the stream flow at that given point. And for our water supply, a range of possibilities of the accumulated runoff. We use this range and we compare it to 30-year normals, which we're now using the new ones, the 1991 to 2020. Our water supply forecast is run daily, but the official forecasts are issued on the first of the month, similar to the NRCS. And that's just with an extra layer of quality control that is kind of just an extra set of eyes. The graph on the, or map on the right, you saw a zoomed in version of that from Tony Anderson, and I'm just showing here all of the locations where the National Weather Service has water supply forecasts. Next slide, please. This is an example of one of our graphic products. This is for inflows to Buffalo Bill Reservoir. The date is along the x-axis and the volume in kiloacre feet is on the y. So each blue line, which here kind of just looks like the light blue shading, that's the that represents the range of probabilities of the total runoff accumulation from the ESP model on that particular day. The blue dot in the center of it, which because it's plotted every day, just kind of looks like a blue line, darker line, is the 50% exceedance probability. So that is to say, in 50% of our simulations using the historical data, the accumulated runoff was greater than whatever that value is. On the lower end of the blue shading is the 90% exceedance probability, and at the top is the 10% exceedance probability. The red lines that you see on here are our official forecasts, which are made on the first of the month, January to June. The official forecasts might differ a little bit from the daily forecast just because it has that extra layer of quality control. On the line, the red square in the middle is the 50% exceedance probability of the official forecast. And then the upper and lower pink squares are the official forecasted 90 and 10% exceedance probabilities respectively. Finally, the orange shading on the bottom, which you can start to see beginning around April, is what we have as our observed runoff. And our forecasts, once we start to observe runoff, is the forecasted volume still to melt, and then we add in what has already been observed. This information here is located on the Colorado Basin RFC website, which that link is there listed on the right. Next slide, please. Just a note here is that we do produce natural or unregulated and regulated forecasts where that's appropriate. This is done using information that we have about local reservoirs, diversions, returns, etc. And we can augment our natural flows to estimate this water usage. We do this to try to accommodate both users, those who want to know the total water available in the system, and then also those who just want to know how much water is realistically going to pass at a given point. It is important to note that at least for the NBRC, we don't always have all the data available to make these adjustments. So this is an area of continuous ongoing work and, of course, room for improvement. Final slide, please. And the last thing, just to briefly highlight here, are some graphical summaries that we have on the Missouri Basin River Forecast Center page. These include comparisons of forecasted stream flow as a percentage of average to those 30-year normals, and a comparison of observed monthly precipitation compared to the 30-year averages. And that is all for me. I will be happy to take questions, but for now, I will pass it back to Kevin.
Awesome. Thanks, Alex. Yeah, so as I mentioned, I'm also going to talk about the Bureau of Reclamation's water supply forecasting program. Until 6 months ago, I was the forecaster at the Bureau of Reclamation, as well as the lead developer on their forecasting software. So their forecasting software at the Bureau is called PyForecast. This is just a snapshot of the user interface. Essentially, the assumption at the Bureau is that people operating the reservoirs generally don't have time or maybe training required to go out and do a lot of physical modeling for runoff forecasting or really in-depth statistical modeling. And so we developed the software to make it very simple to find all of the data within your basin and have a piece of software do a lot of that statistical modeling for you. So next slide. So similar to the NRCS, the Bureau software goes out and grabs lots and lots of data and tries to come up with linear regression models to correlate April through July stream flow with various types of predictors. I've listed some of them out here. There's SNOWTEL, SWE values, rain gauge precipitation, drought indices such as PDSI or evaporative losses, antecedent stream flow, climate indices, things like that. And so what it's going to do with all of those predictors, like I said, it's going to try to come up with a correlative statistical relationship using linear models. And then it's going to take an ensemble of the best performing linear models and give you a range of inflows at 50% exceedance inflow, as well as the any uncertainty levels you want. Next slide. So like I said, so if we're looking at this plot on the right, there may be 5 individual models behind this thicker kind of brown curve, which is the ensemble model. So it's doing is just taking each of those individual models, the predictions from those. It's using a bootstrapping approach to come up with a uncertainty interval around the median predicted inflow. And it's combining those 6 or 5 individual models into one ensemble model and giving you a kind of final answer for your predicted inflow. This software is available for public use. Anybody can go and download it. It is on GitHub. If you do a Google search of PyForecast USBR, you are welcome to download it and try to come up with your own forecasts. It is pretty flexible. You can forecast anything you want, not just stream flow. You can forecast stock prices or Doritos prices, things like that. Doesn't really matter what kind of data you feed it. But yeah, like I said earlier, happy to take any questions after the presentations. Thanks.
All right, thanks. And thanks to all our presenters here today. And I'll just kick her back to Danelle.